Okay, here we go. Good morning. So we're going to do the second part of the genetics PowerPoint today. And so we're going to learn about monohybrid crosses. So monohybrid cross just means, mono means one, hybrid is a cross. So when I say monohybrid cross, what I mean is that we're going to take a single trait and cross it with another single trait. In this instance, we're looking at flowers. So if you'll look here, let me mark for you. This is capital P, and lower p, which tells me that purple is dominant to white and that this is the P generation and they're both pure strands. Now, to create this Punnett Square, which I know you guys did in the 7th grade, so this should be easy. Basically, you're going to set up a square for every possible combination that could come out of this cross. And since these gametes each have 2, you have to have a square for each one. So 2 squares for these 2 gametes and 2 squares for these 2. So we're talking 4 squares. You can put these parents on either side. It doesn't matter. So in this instance, we've put this parent here, right? You see that capital P, and then this parent is on this side over here with the lowercase letters. Okay, so now we are going to go ahead and fill in our squares, and the way we do that is we just bring this letter down and this letter over. Okay, so we would do something like this. Okay, so what you should see is that we always put the capital letter first, we always put the lowercase letter second, and we always put like letters together. So that's the number one rule you've got to remember when doing Punnett squares. Okay, so if this is big P, little p, then this one over here would be big P, little p, and this one down here would be big P, little p, and this one over here would be big P, little p, because the parents are all the same. So all they have to give, this one only has big P's to give, and this one only has little p's to give. So you got to have big P, little p, and all of them. So what we would say is in the F1 generation, which would be the offspring in the square here, all the offspring will be heterozygous and all of them will be purple. So our genotypic ratio would be 100% heterozygous and our phenotypic ratio would be 100% purple. Easy, right? All right, let's do the next one. Okay, there it is. All right, so this time we're going to look at bunny rabbits, and we're going to look at monohybrid crosses of a homozygous parent, which is this bunny over here, so this bunny right here, and then we're going to do a heterozygous parent, which is this bunny right here. Now, let me move me a little bit. What you can see is that big B indicates they're black, so black is dominant, and little b is brown, so brown is recessive. Okay, so let's put our parents on the side of our Punnett square. So there is this parent here, and here is this parent here. Okay, so if we are going to fill in the squares, all we do is we bring this letter in and this letter down. So this square right here should be what? That's right, big B, big B. Okay, and right below it, we've got a big B coming down, and we got another big B moving over. So again, this square right here would be what? That's right, big B, big B. Okay, so now we got a little different party going on over here. So we're going to take this B, and we're going to move it all the way over, and this B all the way down. So this square right here is going to be what? That's right, big B, little b. And then right below it, because we have the same scenario, we're going to have the same result. Okay, so now here's where we get interesting. So phenotypic ratio, remember phenotypic, so that talks about what are they going to look like. So the baby bunnies in our F1 generation, are they going to be black or are they going to be brown? Okay, so let's take a look. This one right here should be what color? That's right, black, because it has 2 capital B's. And the one below it the same, because they are the same. On this side, though, we have that little b. Can we see the little b if the big B is in front of it? No, we cannot. So this one will be black as well. So all of our F1 generation should be black, 100% black. Okay? All right, now let's do genotypic ratio. So if we did a genotypic ratio, what do we have here? Well, we have 2 different genotypes, right? We have a big B, and then we have the heterozygous over here. So we have a homozygous dominant for every heterozygous that we have. So it's a 1-to-1 ratio. Or you could say 50%. That would work as well. So 50% big B, or homozygous dominant, and 50% heterozygous. It's very simple. All right, let's do one a little more complicated. All right, let me clear my screen here. Okay, so heterozygous by heterozygous. That means we're going to look at this black bunny, and we're going to cross it with this black bunny. So far, super easy, right? So what are we going to do? We're going to put our gametes, that's these letters right here, on the side of our Punnett Square. So let's do that. I hope you're doing these on a piece of paper. It just makes it easier for you guys to follow along. Okay, so now let's do this part here. So we're going to put this in this square and this in this square. So what are we going to have in this square right here? That's right. It should be homozygous dominant or big B. Okay, right below it, we've got this B coming down and this B coming over. So right here, we should have what? Yep, heterozygous, big B, little b. Okay, moving over here, we've got the same issue. We've got a big B and a little b. So what should go in this square? That's right, heterozygous, big B, little b. Okay, and then down here in this corner, you've got a little b here and a little b here. So in this corner, we're going to have a homozygous, but it's going to be recessive. So we have homozygous recessive, or little b, down in this corner. Okay, so here comes the hard part. All right, so now, what is your genotypic ratio? Remember, genotype refers to the letters. So we're looking at big B, so homozygous dominant, we have 1. Then we have 2 of the heterozygous and 1 of the homozygous recessive. So if we do this in a ratio, it would be a 1-to-2-to-1 ratio. Now, if you wrote it in a percentage, you would have 25% homozygous dominant to 50% heterozygous to 25% homozygous recessive. So it could be done in percentages too. So now, what's the phenotypic ratio? So let's look back in here at our genotypes. So big B is going to look like what? That's right, it's a little black bunny. Okay, big B, little b is going to look like what? That's right, just like the parents, it should also be a black bunny. But now we got down here, we have no big B's. So all we see are little b. So in this square, we're going to have a brown bunny because the black isn't there at all. Okay, so what is our phenotypic ratio? Well, it would be 3-to-1 or 75% to 25%. Okay, so any questions? I don't think we have any questions. Let's see, what's my next slide? Oh, we're going to practice. Okay, so this is the slide we stop on. I've got 2 worksheets attached to it, but since I had trouble the last time, I'm going to go ahead and post them as PDFs on Classroom so that you can download them yourself if you want to. And we're going to practice. And then Wednesday, I would like to do a couple of Zooms, and we will talk about it then. So good luck, have fun, and that is all for this one.